Hello, everyone, and welcome back to the Tony Livins podcast. I'm Tony Livins. Over the last few episodes, we explored some of the most important technologies behind modern artificial intelligence. We talked about deep learning, we explored large language models, and we looked at transformers, the breakthrough architecture that powers many of today's most advanced AI systems. Now it's time to tackle one of the biggest questions in artificial intelligence. Can AI actually reason? It's a question that appears everywhere. People ask it after seeing ChatGPT solve programming problems, after watching AI explain scientific concepts, after seeing models perform well on exams. Many people walk away thinking, if AI can do all of this, surely it's reasoning. But is it? Or are we confusing intelligence with something else? Today, we are going to explore what reasoning really is, how humans reason, how AI approaches reasoning, and whether today's AI systems truly think in the way we do. Let's begin. Before we ask whether AI can reason, we first need to understand what reasoning actually means. Reasoning isn't simply knowing facts, it isn't memorizing information, and it isn't repeating something you've seen before. Reasoning is the process of reaching conclusions using information, evidence, and logic. Imagine someone tells you the road ahead is flooded. You immediately conclude, I should probably take another route. Nobody had to tell you what to do. You connected the information and made a logical decision. That's reasoning. Humans reason every single day when choosing a career, when planning a journey, when deciding what to eat, when solving mathematical problems. Even when trying to understand another person's emotions, reasoning allows us to go beyond information. It allows us to make decisions. Now let's look at important types of reasoning. The first is deductive reasoning. This starts with a general rule. For example, all human needs oxygen. Tony is a human. Therefore, Tony needs oxygen. If the first statements are true, the conclusion must also be true. Deductive reasoning is common in mathematics, computer science, and formal logic. The second type is inductive reasoning. This works differently. Instead of beginning with certainty, it begins with observations. Imagine you see the sun rise every morning for years. Eventually, you conclude the sun will probably rise tomorrow. Notice the word probably. Inductive reasoning deals with likelihood rather than certainty. Scientists use this type of reasoning all the time. They collect evidence, identify patterns, then build theories based on those observations. The third type is abductive reasoning. This is reasoning to the most likely explanation. Imagine you wake up and the streets are wet. You didn't see what happened overnight, but you conclude it probably rained. Could there be another explanation? Of course. A street cleaner, a bus pipe, someone washing their car. But rain seems like the most reasonable explanations. Doctors use abductive reasoning every day. Detectives do too. They gather clues and determine the explanation that best fits the evidence. Now let's ask an important question. Can artificial intelligence perform these kinds of reasoning? The answer is sometimes, but not in the same way humans do. Modern AI can often produce answers that looks like reasoning. It can solve mathematical problems, write computer programs, summarize research papers, even explain complicated scientific concepts. But there is an important difference. The AI isn't sitting there consciously thinking through the problem. Instead, it's using patterns learned during training to generate responses that often resemble logical reasoning. Imagine someone has solved 1 million max problems. Eventually, they become very good at recognizing which method usually works. That doesn't necessarily mean they are consciously analyzing every step from first principles each time. Modern AI behaves in a similar way. It has seen enormous number of examples. When presented with a new problem, it predicts the reasoning process that mostly likely leads to a useful answer. One of the biggest breakthroughs in recent years has been something called chain of thought reasoning. This simply means encouraging the AI to work through a problem step by step instead of jumping straight to an answer. For example, instead of asking, "What's the answer?" you might ask, "Think through the problem step by step before answering." Interestingly, researchers discovered that this often improves performance. Why? Because breaking complex problems into smaller logical steps reduces mistakes. Humans often do exactly the same thing. When solving a difficult maths question, most of us don't instantly know the answer. We write down our working, we solve one step at a time. But here's something fascinating. Just because an AI produces a chain of reasoning doesn't necessarily mean that's how it internally reaches its conclusion. The explanation itself is also generated language. It's another prediction. That makes evaluating AI reasoning an active area of research. Researchers continue asking, is the model actually reasoning? Or is it producing text that resembles reasoning? Let's think about chess. Modern AI systems can defeat the world's strongest chess players. Does that mean they understand chess the way humans do? Not necessarily. They evaluate millions of possible positions incredibly quickly. Humans often rely on intuition, pattern recognition, long term planning, experience. Both reach strong decisions, but they arrive there differently. The same applies to language. When ChatGPT explains a scientific concept, it isn't recalling a classroom lesson. It didn't sit through lectures. It didn't perform laboratory experiments. It learned statistical relationships between words, ideas, and concepts during training. That's fundamentally different from lived experience. Another important area is planning. Reasoning isn't only about solving problems, it's also about planning for the future. Imagine you're organizing a holiday. You need to book flights, reserve a hotel, pack luggage, arrange transport, manage your budget. Humans naturally organize these tasks into a sequence. Modern AI is becoming increasingly capable of planning like this, especially when combined with external tools and memory systems. This is one reason AI agents are becoming such an exciting field. We will explore those in a future episode. Let's also talk about common sense. This is one of AI's greatest challenges. Humans possess enormous amounts of everyday knowledge. For example, if I tell you, I put an ice cream on the dashboard of my car during summer, you immediately know what happens next. The ice cream melts. Not because someone taught you that exact sentence, but because you have experienced heat. You have experienced ice cream. You have experienced time. AI doesn't have those experiences. It learns relationship from text. That difference matters. Now, here's another misconception. Some people believe reasoning automatically leads to consciousness. It doesn't. A calculator performs arithmetic. That isn't consciousness. A navigation system finds the fastest route. That isn't consciousness. Likewise, an AI may solve difficult logical problems. That still doesn't mean it possesses awareness or subjective experience. Reasoning and consciousness are different concepts. One involves solving problems, the other involves experiencing existence itself. So, can AI actually reason? The answer depends on how we define reasoning. If reasoning means producing logical solutions to complex problems, then today's AI systems have become remarkably capable. If reasoning means conscious reflection, understanding, self awareness, and genuine comprehension, then we are not there. Not at least with today's technologies. Modern AI remains one of the most impressive engineering achievements in history, but it is still fundamentally based on mathematical computation, not lived experience. As researchers continue improving AI, reasoning capabilities will almost certainly become more advanced. Models will become better at planning, better at solving unfamiliar problems, better at combining information from multiple sources. But one question will continue following every breakthrough. Is the machine actually thinking? Or is it just becoming increasingly good at predicting what thinking looks like? That question may shape artificial intelligence research for many years to come. Perhaps the most important lesson from today's episode is this: we shouldn't underestimate AI, but we also shouldn't misunderstand it. Understanding both its strength and its limitations allows us to use it responsibly. Artificial intelligence is an extraordinary tool, one that can amplify human knowledge, creativity, and productivity. But the responsibility for asking good questions, making ethical decisions, and applying wisdom still belongs to us. Thank you for listening to episode 12 of the Tony Levins podcast. I hope today's discussion gave you a deeper understanding of what AI reasoning is, what it isn't, and why this question remains one of the most fascinating topics in artificial intelligence. If you enjoyed this episode, I really appreciate if you subscribed, shared it with someone interested in AI, and left a review. In our next episode, we are moving beyond language and into vision. We will explore computer vision, how AI learns to see the world. How can a machine recognize faces, detect diseases from X rays, identify objects in real time, and even help drive a car? We will answer those questions and much more. Until next time, this is Tony Livins. Take care, and I will see you in episode 13.